Okay, this is the Math 1113 Zoom meeting for March 11th. And question on the table is MyLab. Cosecant of x is 3. That'll mean sine of x is 1/3. You realize you can, they want you to solve for x with cosecant of x equal 3. All answers on 0 to pi. All right, do you know that you can flip both sides? And that will change this to a sine and then flip 3 and you get 1/3.
Okay, I perhaps had heard that, but I wasn't thinking of that for this context. So.
Okay, yeah, because see, ultimately to solve for x, you've got to undo this function, which means you need an arc sine.
Right.
There is no arc cosecant.
Right.
So arc sine there, we'll need arc sine or inverse sine of x is then inverse sine of 1/3, inverse sine of 1/3. So that these cancel, leaving the x, and this will give us our first answer. Radian mode. So inverse sine 1/3. All right, 3398. I guess we'll just use 4 places. All right, so let's answer 1. You followed it that far?
Yes, sir.
Okay. For more answers, this is why it's important to be able to sketch this out and figure out what the calculator is telling me. This is the angle. So you take sines of angles.
Right.
It's saying if I take the sine of 0.3398, I'll come up 1/3. In radian mode, these things for small angles are real similar. This is the y coordinate.
Right.
So I form a little angle. The angle is 3398. And the vertical side, the y coordinate at that side is 1/3.
Okay.
It's supposed to be vertical, sorry about that. So then on 0 to pi, pi being over here, you want to sketch out another situation. So this in effect is the reference angle, 3398. And you'll have this side reflected over here being 1/3.
Right, okay.
So the other angle is measured from 0 around to there. So the other angle, I'll just write it down in English, will be pi minus 0.3398. Pi minus 0.3398. 2.8018. You can easily check. If I take the sine of 2.8018, I will get the y coordinate out. It'll be the decimal for 1/3, which should be 0.3 repeating. Sine of 2.8018, 8018. Yeah, I get 3 3s out of the repeating and then almost a 3. That's as close to 1/3 as you're going to get with the round off error.
Okay.
Does that convince you?
Yes, sir. That makes sense.
391, which is basically or about 1/3.
Okay, thank you.
Okay. Are there other questions?
No, sir. That was it.
Okay.
All right, well, thank you for your help.
Well, certainly.
Have a nice day.
Okay, absolutely. I'm going to continue on with graphing in 6.3. So yeah, you have a good rest of your day.
Thank you.
Uh-huh. Okay, we'll continue on section 6.3. We're on page 531. And just to remind everybody from Monday, a sine curve, y equals sine of x, starts in the middle, goes up and down and up and down and up and down, up to 1 and down to -1, and it goes backwards. Same way, it's uniform, it's tough to draw it uniform. Y equals cosine. They're both generically called sine curves, but if it technically comes from the cosine, it starts high, it's up and down and up and down. In effect, this peak has been shifted back 90 degrees. So you can get a sine curve from a cosine formula if you show the right horizontal shift. The model is y equals a sine of k and then an x minus b plus, I like to show a vertical shift. And y equals a cosine of a k, x minus b plus a vertical shift. Vertical shift. All right. Amplitude is the absolute value of the a. It's the distance from center to the peak, positive distance. The period on this one runs from here to here, is 2 pi divided by the k value. On this, it runs from here to here, 1 period. The horizontal shift is equal to the b, and it is basically it measures how far this has been shifted. Either here, if you got another horizontal shift, in other words, on a sine, here's the regular curve, normal curve, a regular curve, and then if you got another one's doing this, this little distance here is your horizontal shift, and then VS is vertical shift up and down. They give you the number. So in other words, if it's doing something like this, that has vertical shift. All right, well, they kind of divide these into two sections, and one that has, say, both 15, page 531, 15 equals 3 plus 3 cosine of x. And we'll have you fill in a worksheet. The graph, amplitude, period, horizontal shift, horizontal is one eye there, horizontal shift. You can tell that is equal to 0. You can twist this around and write it 3 cosine of x add 3. And if you then go 3 cosine of k, then x minus b, the extra parentheses there, add your vertical shift. You can tell b is 0. It's the b, and vertical shift is also 0. I'm sorry, golly, vertical shift is 3. My apologies. All right, period is 2 pi divided by the k. And your k is the coefficient on the x, so that's equal to 1, so that's just 2 pi. And your amplitude is the absolute value of the coefficient in front, and that will be equal to 3. If you want to do the graph down here, where I got a little more space, you're going to find this one shifted up, the vertical shift shifting this up 3. That's where it's going to be centered around. And then it's going to go with an amplitude of 3. It's going to go up 3 above that. And it's a cosine, so it's in no horizontal shift. So cosine starts high. It's going to be a straight cosine with no horizontal shift. So it starts high. It's going to go down, and it's going to go 3 below the center. Back up to 6, and then back down 3, and then it does the same thing in this direction. And so on. So yeah, if you know what you're doing, you can sketch them by hand. But of course, you're free to graph them on the calculator and copy down what you see. So we have 3 plus 3 cosine x. See, being able to sketch it out by hand kind of helps you set the window. I guess I'll go horizontally, 0 to 2 pi, just to do one period. 0 to, let's see, 2 pi. You can pick any fraction of pi you want. On the scale, you can pick 1. Just keep it 1. Keep it simple. And we'll go 0 to 6 by 1. Graph. So there you are. I'm starting the graph here. And it's graphing through one period there of 2 pi. And you should be able to see it's going up to 6. 1, 2, 3, 4, 5, 6. Yep. And coming down to 0. It does not show the center line unless you want to literally graph y equals 3 to show a center line. If it's worth doing or not. 3. Yeah, there you are. You can see what it's centered around. You have to do that separately. All right. 17 is a little bit strange. The absolute value of cosine x. Just trying to sketch out what it's going to do. Your straight cosine of course does this. All right. So remember, this is always positive. So if you're above, you're positive. If you're below, you're negative. And it's going to change to positive. Positive. So 0 is going to be the connecting point. This stuff is going to flip up. Right here, you're going to flip up. But these up humps won't change. Here, here. All the up humps will be fine. They're already positive. The negative values given these down, it's where the x coordinates went negative on the circle, they'll flip up, and you're going to get literally a series of boom, 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 boom. All right, now the trick is on the calculator. Absolute value is under math, num, number 1. So y equals clear, clear. Math, num. Num is across the top, and then number 1. My calculator says ABS. You stick what's between the bars in the parentheses. The modern ones have literally straight bars. So cosine x window, I get, yeah, I can run 0 to 2 pi by 1. 0 to 6, a little big. I'll show you what happens when you do 0 to 6. Yeah, it's, you can see that. There you are. And if you want to see it a little bigger, you can change the window, maybe 0 to 2. There you are. See that this middle hump, you're starting off straight, the one near the y-axis, and then this original hump would have been low, would have been this low, and it's been flipped up. And then you've got the end hump to fill the period. All right, why don't we try some that are a little trickier? In horizontal shifts in graph 1 complete period. I think I did 39 the other day. Why don't we try 33? Page 531. Cosine of x minus pi over 2. All right, and then we want to match to a cosine of a k, and then x minus b, and then add vertical shift. In the worksheet, okay, can you tell your amplitude? Absolute value of 1, which is 1. Period is 2 pi over the 1. Coefficient is 1, which is just 2 pi, still 2 pi. Now your horizontal shift, can you tell your k is 1? This is 1, this is 1. This coefficient here, the coefficient on the x is 1. X minus pi over 2, x minus b, your horizontal shift is pi over 2. And the vertical shift, 0. There's nothing added on here to shift it up or down. This is probably going to look like a sine wave. Cosine x minus pi divided by 2. Window 0 to pi. We'll want it. We'll want negative numbers, so let's say -2, just so it looks graph. Yeah, see, that's indistinguishable from a sine wave. That is exactly what a sine wave is. And to even prove it, you can punch in the number. This is equal to a straight sine of x. You'll get the same numbers out of both formulas. This is a cosine shifted back pi over 2, or shifted actually forward pi over 2. And then this is straight sine. Just to show that cosine of an x minus pi over 2 is identical to a sine of x. You know, test x equals 3. So a cosine of 3 minus pi over 2, and on the other side, a sine of 3. If we don't get the same number out, I'll quit on the spot. 3 minus pi divided by 2, 11411. And on the other side, a sine of 3, and you get the same thing. Remember what the 0.141 was. You can see it easier from the sine of 3. You're at 3 radians. This is pi at 3.14. The y coordinate is 0.1411. And you can get it from cosine shifted back, shifted right pi over 2, or you can get it from a straight sine. That is absolutely fascinating to me. It may not be fascinating to thee. Okay. Do we have any? Nope. Okay. So let's see, what others can we did 39 the other day. You've done 35. Why don't we try one, yeah, a tricky one like 45. It's written backwards, sine of pi plus 3x. All right, let's switch it around and write it sine 3x plus pi. All right, and again, the worksheet. Or we can compare it to y equals a sine of k, and then x minus b, add your vertical shift. Okay, worksheet, amplitude. Tell is absolute value of 1, which is 1. Period. 2 pi over the 3. Nothing you can really do to reduce that. Horizontal shift. This is where it gets tricky. Equals sine, and I've written it 3x plus pi. Okay, need to factor out the 3. Equals sine of 3, then a parentheses, then your x. So there's your 3x. But it can't be plus pi. That would give you a 3 pi when you multiply it back. It's pi over 3. And if you really want to make it obvious, make it sine of 3 and then x minus a negative pi over 3. See, so x minus b, x minus negative pi over 3. Your horizontal shift, negative pi over 3, which means it's a left shift, pi over 3. Which if you remember from college algebra, as it should be, but it's pi over 3. It's not a left shift of pi. It's a left shift of pi over 3. And there is no vertical shift. Vertical shift equals 0. Let's see if we can get a graph of one period of this. So let's see, y equals, you can do it, sine of originals pi plus 3x. Window, 0, one period is 2 pi over 3. Maybe X scale 1. And basically centered around 0, amplitude is 1, the negative 2, 2 is fine. You can do negative 1, 1. Graph. So this has been shifted. All right, so starting here, doing this. That should be 2 pi over 3. Amplitude is 1. And the horizontal shift is negative pi over 3. All right, let's check this one in the back. 6, 3, 45. You know, I've got everything right, but the darn graph. Oh, no. Okay. All right. So there's your amplitude of 1. There's your period of 2 pi over 3. And the horizontal shift is negative pi over 3, as we said. Now, I'm not getting the graph to match. Basically, I did put in enough of a scale to get this, and then I went out one period for it to continue on. All right, if you want the graph to match what they have, I need to put in an x min of negative pi over 3 and x max of pi over 3. Let me do the book. Okay, So book window is going negative pi over 3, let's say by 1. And I'm doing, I can do negative 1, 1, say 0.5. Okay. Window, negative 3. Instead of going forward one period, they're centering it around the y-axis, and then pi divided by 3. I guess I'll do 1 or maybe a 0.5. It doesn't really matter. And then negative 1, 1. I say 0.5. Okay. And now you've got a graph that matches what they have. Going up to 1, down to negative 1, from negative pi over 3 to pi over 3. Yeah. So, neither graph is wrong. I just used a different scale and just graphed it one forward period, whereas they graphed it one period back this way. Look. It went from here to here. Questions about that? All right, let's see. Why don't we try one like 43 real quick? Page 531. 3 cosine pi and then x plus a half. Once again, we're going to match 3 cosine of k and then x minus b plus your vertical shift. Right, amplitude tells absolute value of the 3, which is just 3. See, what happens is they'll make 3 negative, and then you'll just use negative 3, because when this is pi, you just get so used to using the same number when it's positive that you forget if this is negative to make it positive. Period will be 2 pi over pi, 2 pi over the k, which is just 2. Horizontal shift. Shift. Okay, now the pi is already factored out. Can you tell your b's got to be a negative a half? So you have negative, negative a half, giving you the positive half. B is negative a half. Vertical shift. Hope you can tell there's nothing added on. Must be 0. If you, let's see, to avoid a little freak out, if I want to match the book, I guess I'll use the window in the book. 530 USC 6343, and it's 6343. Okay. Periods, amplitudes 3, periods 2, phase shifts negative a half. I wish they'd label them, but in the order that they ask them, your amplitude's 3, your period's 2, phase shifts or horizontal shifts negative a half. And they're going negative a half to 3 halves horizontally, and from negative 3 to 3 vertically. Okay, so they're going negative a half to 3 halves. So use 0.5. This is your x min, x max, x scale, and they're going negative 3 to 3. So use 1, y min, y max, y scale. All right. Y equals 3 cosine pi parentheses x plus 1/2. Window -1/2. 3/2, 5, and -3, 3/1. Graph. All right, I'll leave that on the screen. And hopefully you can tell that, yeah, it looks identical. All right. Well, that is the scheme or rules for sines and cosines graphing. And next week, we get the other 4, secants, cosecants, cotangents, and tangents, and they're going to have asymptotes and look completely different. And there'll be much fewer things to read off their graphs as well. Much, much fewer. Well, I know you can't wait. Coming attractions. Email me with any questions, and we'll see you in Zoom sessions next week. Thank you.